Over inequalities. Before we do that, let's go over what we remember about multiplying and dividing equations. Shauna noticed that the distance from her house to the ocean is 40 miles. It is 1/5 the distance from her house to the mountain. Write and solve a division equation to find the distance from Shauna's house to the mountains. You know, they didn't give us enough information. They didn't tell us the distance from the house to the mountain. So I'm going to use the letter M. Ooh, I see the word is. So the distance from her house to the ocean is 40 mile. 40 mile was 1/5 the distance from her house to the mountain. So remember, is and was is telling you is equal. 40 is equal to 1/5 of the distance from the house to the mountain, or M. Another way to think about it is through rectangular model. This is the distance from the house to the mountain, but from the house to the ocean is 1/5 of it. Each fifth has 40 miles. So what is the distance from the house to the mountains? So from this, we can use our inverse thing. What is I want to keep this M, isolate this M. What is the inverse of divide by 5? Times 5. Times 5. So 5 times 40 is 200 miles is equal to the distance from the house to the mountain. As you can look at your rectangular model, you see every fifth is 40 miles. Another fifth is 40 miles. Until you have 5/5, which is 200 miles. So again, 40 mile is 1/5 the distance from our house to the mountains. So that's why I put every fifth is 40. All right, so in inequalities, you probably learned in elementary school as the alligator symbol, but we don't use that in junior high or high school, college. You'll be laughed at, I'm sure. So what are they? So we have less than, greater than, less than or equal to, or greater than or equal to. You've got to be familiar with these. So let's start with the first one. X represents any number. X is a variable. It can represent any number I want it to be. If the inequality is facing this way, it's saying is less than, or another way to say it is fewer than. Can you list me possible numbers that are less than or fewer than 5? 4, 3, 2, and 1. Can it include 5? Is 5 less than 5? No. It can't be less than itself. So anything less than 5, 4, 3, 2, 1, 0, -1, -2, -3, all those numbers are less than 5. What about this one? If it faces this way, can you name numbers that are greater than or more than 6? 7 is greater than or more than 6. 8, 9, 10, 11, 12, and possible. Next one. X, so next one is less than or equal to or at most. I promise you in the upcoming activities and tests and quizzes and assessments, you've got to know to be able to distinguish this. This means less than or equal to or at most. Please memorize this. At most. At most is represented by this. Wait, how is direction? So x is less than or equal to 4. Can you name numbers that are less than 4 or equal to 4? So we can use 4. 4 is less than or equal to 4, at most. 3 could be at most. 2, 1, 0, -1, -2. All these numbers at most reach up to 4, but less than it and equal to it. And the last one are greater than or equal to or at least. Can you name numbers that are at least 6? Barely 6 or equal to it? Well, 6 is at least 6. 7 is at least 6. 8 is at least 6. 9 is at least 6. 15 is at least 6. Or greater than or equal to. So as we look at this, we are going to be working on a lot of number lines. So on this number line, how do you compare rational numbers on a number line? What do you remember? We talked about this many, many moons ago. In the number line, where do you find the least numbers and the greatest number? L to G. the least numbers are located on the left, the greatest number are located on the right. So if there were two numbers like -1 and -3, -1 is greater than -3. So -1 is greater than -3, or -1 is more than -3. Another way you could say it is, you write that this way. -1 is greater than 3. Many ways to do it. So -1 is greater than 3, or you can read it this, -3 is less than -1. Either way is correct, it's saying it. So let's practice this. True or false? Using your number line, can you tell me which one is which? So let's look at it. Here is 7 and 5. Which one is greater? 7 is more to the right, so this is true. 5 is less than 7, which is true. Next one. -3 is greater than -7. Is that true? Is -3 really greater than -7? Here's -3. Here's -7. Is -3 greater than? Yes, it is. So that's true. 8 is less than or equal to 9. Is 8 less than 9 or equal to? That is true. And next, -2 is greater than or more than or equal to -5. Is -2 greater than or equal to -5? Let's look at our thing. Here's -2, here's -5. -2 is greater than or equal to -5. It's true. So now, what we're going to be doing here is we're going to plug in, see different scenarios when the statement is either true or false. So the first one. If I plug in either 35 or 32 into this inequality, will the answer be true still? So the statement is x plus 8 is less than 40. So if I erase the x, replace the x with, substitute the x with 30, will 30 plus 8 or 38 be less than 40? True. Next one. If I replace the x with 5, will 5 plus 8 be less than 40? True. If I replace with 32, what's 32 plus 8? 40. Is 40 less than 40? False. It can't be less than the same number unless it's equal to. So, next one. 6 groups of x is less than or equal to 38. So if I replace the x with one of these numbers, 7, -2, or 5, will it be true or false, the statement? What is 6 groups of 7? Is 6 group of 7, which is 42, is 42 less than 38? False. Replace this x with -2. 6 groups of -2. So -2, -2, -2, -2, -2, -2, that's -12. Is -12 less than 38? Definitely true. And next, replace the x with 5. Is 6 groups of 5, which is 30, less than or equal to 38? Definitely true. And the next example, you have -4 groups of x is less than or equal to 20. When will this scenario happen? If I replace it with 3, -2, and -5. In subsequent YouTube video, we will be solving this so you can know exactly when this happened, when this is a true statement. Right now, we're just guessing and checking right now. So if I replace this x with 3, what's 3 groups of -4? -4, -4, -4 is -12. Is -12 less than 20? Of course, that's definitely true. If I replace the x with -2, what's -4 times -2? Ooh. Do you remember when you multiply two negative numbers? Multiply or divide is an easy thought. Same signs are positive. Different signs are not. So it's +8. Is +8 less than or equal to 20? That's definitely true. And next one, if I replace this x with -5. So, multiply two negative. Multiply or divide is an easy thought. Same signs are positive. Is +20 less than or equal to 20? True. So here's our last example. 4 groups of x is less than 52. Before I do this, do you have any guesses? When will this be true? Up to what number? What about 10? Will 4 groups of 10 be less than 52? If that's 40, yes. Can we go up to 12? Is 4 groups of 12 is 48? Is that less than 52? Yes, 48, yes. What about 13? 4 groups of 13, that's 52. Is that less than? No, it has to be, it's less than, not equal to. So I predict it's anything less than 12. Or, sorry, less than 13. So I think this is true, this is false, and this is true. Let's see if that's correct. What's 4 groups of 10? 40. That is less than 52. What's 4 groups of 13? 52 is less than 52? No, cannot be the same number. What's 4 groups of negative 3? Negative 3, negative 3, negative 3, negative 3 is negative 12. Definitely less than 52. Alright, so this is just a brain teaser. Just curious if you can do this or not. Create an inequality, just like what we just did, that when x is 2 and when x equals negative 3, the inequality will always be true. If I add, what should I add to x? I'll just say 5. It will be greater than negative 8. So if I replace x with 2, will 2 plus 5 be greater than negative? True. If I replace this x with negative 3, well, negative 3 plus 5, which is 3 negatives with 5 positive, is 2 positive more by more. Would that be greater than negative? It is. So x plus 5. Let's try another inequality. Can you do an inequality where if you replace the x with 11 and negative 4, it will be true? That's why I'm going to do multiplication. 5 groups of x is greater than 10. I don't know if this is true. I just made it, came in my head. So if I replace the x with 11, it's 5 groups of 11, which is 55. Is that greater than 10? Yes, it does work. If I put this one, 5 groups of negative 4, that's negative 4, negative 4, negative 4, negative 4, negative 4, negative 20. Is that greater than 10? So this does not work. So you know what? I'm going to still keep the x. I'm going to change this number to negative 100. Let's see if this works. If I replace the x with 11, 55 is greater than negative 100. But will 5 groups of negative 4, which is negative 20, is negative 20 greater than or more than negative 100? It is. All right, so now it's time to make it a little harder. So here is a number line. A reminder, a variable is a symbol or letter for a number we don't know yet. Can you name which rational number makes this statement true? Provide some example. So looking at this number line, when will this be true? At what number? A number is greater than 4. Which numbers on this number line will be greater than 4? This is greater than 4. This is more than 4. This is more than 4. So the numbers are 5, 6, 7, and higher. All those numbers, according to this number line, are greater than 4. Next one. On this number line, which numbers are less than 3? Which numbers are less than 3? Well, all of these numbers are less than 3. So from negative 7 all the way to 2. Can 3 be included? No, it has to be smaller or less than. Next one. Let's erase this. So we negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. All right, which numbers on that number line are less than but equal to negative 1? Has to be less than negative 1, but it even can include or be equal to it. So it must be negative 1 is equal to negative 1, of course. But what numbers are less than? Negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. And last but not least, can you name some numbers from your number line that are greater than but equal to 2? Or another way to say is at least. Which numbers are at least 2? At least 2. Well, 2 is at least 2. Let's erase this. 2 is at least 2. All these numbers, so it's 3, 4, 5, 6, 7. All these are, so these numbers are at least 2. And last but not least, can you describe this graph? Can you describe this? According to this, it's like weird. That has an open circle. It seemed like it's 3, but it does not include 3. I see it will include 2, 1, and 0. So it includes numbers. So it seems like all these numbers are less than 3. Less than 3. How would you write this? So how can you set it up with an inequality where it's less than 3? So here's x. Here's 3. Seems like there's an open dot. For some reason, an open dot. We're going to be learning in our next lesson. Open dots and close dot. Open dot means less than or greater than. It does not include it. Less than 3. Would this work? Are these numbers less than 3? So x is less than 3. Is 2 less than 3? It is. Is 1 less than 3? It is. Is 0 less than 3? So x is less than 3. So what can you tell me? All these numbers are less than 3. Less than 3. What can you tell me about these? All these numbers are larger than 6. They seem like they're all more than 6. Is this 6 colored or not? I don't think it's colored. It's not shaded. So it seems like it doesn't include it. So it seems like the numbers are 7, 8, 9, 10. So that means all these numbers are more than 6. More than 6. So how could you set this up? X is more than 6. X is more than 6. We are going to also learn in our next slide, next unit, where another way to do it is, do you see this dark line? It's going towards this way. Do you see how this greater than, more than 7 is facing this way? But we're not going to talk about it yet. So next one, we're just trying to get relations here. So in this one, what can you tell me about this graph? It seems like all these numbers are less than 7. All these numbers are less than 7 because you have 6, 5, 4, 3, 2, 1, 0. But includes the black. That's weird. Unlike these, they actually drew it in like they wanted to include it. Less than 6, but equal to 7. So it's less than 7, but equal to 7. So how would we write this? So x is less than 7, but it's also equal to it. So it has an equal sign, but erase the bottom part of it. Whoops. So it's less than equal to 7. So this is the answer. X is less than or equal to 7. And last but not least, what can you tell me about this one? It seems to include all numbers that are greater than 8. So it's greater or more than 8. Do you think it includes it or not? They drew a black dot like they wanted part of the group. Includes 8. Equal to 8. So how would I write this as an inequality? X is greater than 8. Because what numbers are greater than 8? Will 9 go in this? Yes. Will 10? 10 is greater than 8, but equal to. So inequality is figuring out which numbers are part of the group and which numbers are not part of the group. So you have less than, greater than, less than or equal to, greater than or equal to. You have at most, at least. So it's good to memorize the terms. And then you have to substitute numbers in it to see if it works, if it's a true case. For example, to see if this is a true case, if I plug in a 7, will 7 be greater than 8? No. That's why it's not part of the group. Will 9 be part of it? Is 9 greater than 8? It is. Is 10 greater than 8? It is. And that is inequality.